Okay, let's go through the midterm questions. So first one, fundamental limitation of temporal resolution. I think this was straight out of the book. The speed of sound of the medium is certainly the fundamental limitation. We can't image any faster than we can send sound in and out. Next question. So the next question, sonographer doubles the depth of view or doubles the amount of information they are going to acquire. Then because the frame rate is reciprocal of the time, if you double the time, then the reciprocal is halved, so the frame rate is halved. Next question, if 100 scan lines make up an image and the frame rate is 30 per second, then what happens if you triple? Then pulse repetition frequency is 3,000 hertz. So so it takes 30 times 100 pulses per second to create the image. Then that's 3,000 pulses per second or 3,000 hertz. Next question. The number of lines per frame and the frame rate determine the pulse repetition frequency. True or false? That's absolutely true. And that goes along with the previous question. Next question, when the frame rate is 30 hertz, how long does it take to create a frame? Again, the reciprocal of the frame rate is the frame period. So the reciprocal of 30 is 1 over 30, and the reciprocal of hertz is seconds. And so our answer becomes 1/30th of a second. Next question, utilizing the illustration, answer the following question. Just trying to get it right. So a 4 megahertz transducer, and you've adjusted the time gain compensation perfectly. So with 4 megahertz, we're perfect. And that's represented by the red solid line in the picture here. And so you were given a new transducer with an unknown frequency, and the TGC is adjusted to create the same image. So our image is now identical to what we had with 4 megahertz. But the new TGC settings is above and to the right, so it's this one up here. What is the frequency of the new transducer? Is it greater or less than 4 megahertz? So we had to use more gain because more gain is to the right here, and we had to use it sooner. So obviously we have more attenuation, and so the image must be being taken at a higher frequency because there's more attenuation and we needed more gain. So the answers, as we look down here, we have the choices of less, greater than, or the same. And so it must be greater than because it has to be a higher frequency because we're using more compensation earlier. If we were using less, it would be the next one. Next question. Pulsar generates numerous electrical spikes, which ultimately creates a single pulse sound. This is the description of pulse wave single crystal, or excuse me, pulse wave phased array. Numerous electrical spikes indicates that it's phased array rather than single crystal. So the correct answer is, of course, pulse wave phased array. A continuous wave is made with a continuous voltage variation, not with pulses. So in the question, it says a single sound pulse. So nobody picked continuous wave. That's good. Pulse wave single crystal would not use multiple electrical spikes, okay, to create a single pulse. A single crystal would use a single electrical spike to create the sound pulse. Right, next question. Amplification processes all reflected signals in a similar manner. That's true. Amplification amplifies everything. It is your compensation that amplifies it in different manners. Next question. Which of the following is not a function of the receiver? Of course, attenuation is a function of the receiver. That's a result of the media. Next question. Which of the following is the best when the image on your ultrasound displays reflectors in a region near the transducer but nothing deep? Well, that's certainly you can use a lower frequency, which is not one of the choices, or you need to adjust the system's compensation. So the answer is certainly the first response, adjust the system's compensation. Next question, how many shades of gray can be represented by a group of 2 bits? So that'd be 2 to the n, where n is the number of bits that you're using. So 2 to the 2 is 4, so that's 4 shades of gray. In modern elastography, how are tissues deformed? And that's automatically, it uses a pulse that goes into the tissue. It forms what's called a shear wave that goes out and then can be measured to see the differences in tissue stiffness. And so automatically is a really good answer for that. Next, which of the following scan converters will provide the best spatial resolution? Most pixels provides the best spatial resolution. So the answer is 1000 by 1000, which is the most pixels. How many bits are required to store 234 shades of gray? And in this case, you would have your answers are 4, 5, 8, or 256. And so if you picked 5, then if you put 2 to the 5th, so 2 times itself 5 times, would give you a result of 32 shades of gray. So 5 bits would give you 32 shades of gray. 8 bits would give you 256 shades of gray, which is plenty of shades of gray to include 234 shades of gray. So the answer is 8 bits. Which of the following techniques is used to create image data where none really exists? And that describes interpolation. Everyone got that correct. After compression, a signal with the ultrasound system has a dynamic range of 70 decibels. The original signal was compressed by 40 decibels. What was the dynamic range of the original signal? So now after compression it's 70, before compression, before reducing that by 40 decibels, it had to have been 110 decibels. So that's an easy answer. Next question, a signal within the system's receiver has a dynamic range of 60 decibels after compression. The original signal was compressed 50 decibels. What is the dynamic range of the original uncompressed signal? Again, that's 110 decibels. Everybody that got that question got it correct. Sound with a frequency of 4 megahertz is created by the transducer. What is the harmonic frequency? And we always describe the harmonic as being the second harmonic, and that is 8 megahertz. It's simply a doubling of the frequency. So everyone got that correct. What nonlinear behavior creates contrast harmonics? Remember, contrast harmonics are created at the reflection of the sound. The propagation harmonics are created as the sound travels. So we're looking at the reflection of sound, and microbubbles tend to expand greater than they contract, and that is the correct answer for contrast harmonics. The correct answer for propagation harmonics is that sound travels faster in compressions than in rarefactions. Which of the following is associated with the highest mechanical index? And so remember, the highest mechanical index is the greatest rarefaction pressure and the lowest frequency, which means that it's at lowest pressure for the longest period of time, which is answer A. Everyone got that correct. Which of the following creates harmonics? Nonlinear behavior. So we were more specific in an earlier question as far as contrast and propagation harmonics, but the truth is that any nonlinear behavior can create harmonics. Where are harmonics created? They are created in the tissues. All right, so next, a ultrasound transducer generates what kind of sound into the body? And the answer is a pulse of sound. Um, we always create pulses of sound in order to do imaging. Within those pulses are waves. Next question, three-dimensional imaging requires many adjacent structure blank to build the image, cross sections. So this is a description of what was written in the book on how this is made. So three-dimensional imaging requires multiple cross sections to build up the three-dimensional image. And next question, the pulse repetition frequency in real-time imaging typically ranges from what to what. And if you remember that we said that in ultrasound, the pulse repetition frequency is generally within the range of audible hearing. And so the only one of these which is within the range of audible hearing is 4 to 15 kilohertz. So that is the correct answer. Sonography is medical anatomic imaging using blank technique. And again, pulse echo technique is our correct answer. And if you want to get actually more specific, the only tool that we really have for doing ultrasound is the pulse echo. We send out a pulse, we get an echo. That is utilized for everything that we do, from Doppler to harmonics to everything. It's pulse and echo comes back. So pulse echo is absolutely the correct answer on this. The blank is where the action originates. This should be beamformer or pulsar is where the everything is started. So if you said pulsar or beamformer, you're correct. Another term for this is the transmitter, specific thing. So pulsar, transmitter, beamformer are all pretty much synonyms for each other. The maximum frame rate permitted for a 15 centimeter penetration depth, 3 focuses, 200 scan lines per frame is blank hertz. And so what you do is you calculate the time it requires to go 15 centimeters deep, which is 13 microseconds per centimeter, so 13 microseconds times 15 centimeters. You multiply that times 3, you multiply that times 200, and we end up with a certain number within that would be in kilohertz or millihertz. And then you take the reciprocal of that, and we end up with 8.5 hertz. So yeah, the time to scan, to send the pulse 15 centimeters, which is 15 times 13 microseconds, times 3, times 200, gives you a period of time in seconds. Take the reciprocal, gives you hertz. Everyone that got that question got it correctly. And since it was straight out of the book, I'm not too surprised. Next, Utilizing multiple focal zones simultaneously increases the image detail resolution and degrades the temporal resolution. So anytime we increase image detail, we're pretty much decreasing temporal resolution. Next, utilization of multiple focal points is likely to achieve a longer focus. So you're using multiple focal points, and so you're extending your focus deeper into the patient's body. Which of the following is correct concerning power? Intensity increases proportional to the square of the voltage. So it increases directly to the power, but it increases proportional to the square of the voltage. So the change in area is not affected by the change in power. The change in area has everything to do with the size of the pulse that you send out. Power is inversely proportional to intensity. That's not true. They're directly proportional. And as power increases, area of intensity increases. No, the area is determined by the size of the pulse that you send out. So again, the correct answer is the intensity increase is proportional to the square of the voltage. Remember, voltage is proportional to, voltage squared is proportional to the power. Next question, a computer system that allows digitized images from various imaging modalities to be stored electronically for later distribution and manipulation is called a PAC system. DICOM is what is used to talk to the PAC system. Next, A mode depicts the multiple interfaces along a single line of sight. Another way to say that is A mode describes multiple interfaces along a single pulse of ultrasound. Which of the following is a result of sound refraction? And that is the bending of the path of sound is refraction. So displacement of structures laterally would occur with sound refraction. A point reflector is displayed as a horizontal line on B mode imaging. What may cause this? That is, we did this in the lab. That is the beam width. Okay, so if you're looking at a point reflector, you can imagine one of the nylon strings inside the phantom, which shows up normally as just a simple dot. What makes it look more like a horizontal line? That is the beam width. If you extend the beam width out, then you would see that is causing it to become spread out much more like a line than as a point. Arrays are operated in two ways called blank and blank. Sequencing and phasing is the correct answer, and the actual response should be phasing because nobody uses sequencing anymore. But there's two different ways to get arrays to work, and that's sequencing and phasing. There's two different shapes, or there's multiple shapes you can have of an array, and the two that we utilize are linear and convex. So those are different situations. Next question. A rounded nodule is depicted more clearly with spatial compounding. What is the reason for this improvement in image quality? It's because we're interrogating this nodule from multiple angles. So, next question. Analog to digital converters convert the analog voltage representing echoes to numbers for digital processing. So remember, analog is the real world. Everything comes into us through the real world. We convert it into numbers for our computers to process. And so that's the correct answer, is A, analog into numbers for digital processing. I would actually I'm going to go back through and find out the respondent that put in bits because that's actually correct too, because numbers are recognized as bits. So if that was your answer, send. I think I can click on it and find out. I'll go back and look into that one and give them credit for it too, because I believe bits should be a correct answer. Next question. Which interaction between tissue and sound waves is responsible for converting sound energy into heat? That's absorption. We talked about that in the first part of the semester. Next question. Which type of reflection causes the most intense echo? That is, specular reflectors are the most intense, Rayleigh scattering are the least intense, and scattering are kind of in between. Refraction is not a reflection. Which of the following forms of resolution improves when frame rate increases? So frame rate is directly related to temporal resolution. So good, everyone got that right. Next one, true false. If imaging depth of a scan is 15 centimeters and there are 100 lines in the image, then the number of pulses making up the scan is 1500, and that is false. The number of pulses is 100. You need one for each scan line. So 50-50 on this. Somebody got it right, somebody got it wrong. Next question. What is the time needed to make a single image if the frame rate of an ultrasound system is 20 hertz? Again, we just take the reciprocal of that, which is 0.05 seconds, and there you have it. Okay. Next question. So we saw one similar to this earlier. This is saying that if you're using a 4 megahertz transducer, adjusted the time gain compensation perfectly is represented by the red line. And then you're given a new transducer with an unknown frequency, and we have to make the image look exactly the same as the 4 did. And then now we're having to adjust our compensation less initially and less for each individual point in depth. Then, of course, we're utilizing a lower frequency transducer. And so everyone got that correct. I'm very happy to see that. And of course, it's straight out of the book, so I'm not too surprised. This type of pulsar generates a single electrical spike, which generates a single pulse of sound that describes a pulse wave single crystal. Next, compensation processes all reflected signals in a similar manner. No, that's not true. It actually processes the ones that come later from later echoes or deeper in the tissue with more amplification in order to compensate for attenuation. What is the primary storage device on a PAC system? Those are hard drives. What number of shades of gray can be represented by n bits? And so this doesn't display the question correctly. It is 2 to the n, and 86% got that, which is good. If you saw this question, you would have seen that the first part, it's n to the 2, so it's not n squared. It's not n to the n, and it's not the log of n. It's 2 to the n is the number of shades that are represented by n number of bits. Which of the following is not true about spatial compounding? And the answer is that it can be performed by a mechanical transducer. No, that's not true because we're going in at different angles, which we see here is true. Spatial compounding can eliminate shadowing artifacts, and because you're going in at different angles, you're using multiple pulses, which means that your frame rates are going to be reduced. So the answer is the one that is not true is that it can be performed with a mechanical transducer. I really hate those questions where it tells you what is not correct. You always end up finding, like in this situation, reduced as one negative and not as a double negative. I hate that. Anyhow, What is the number of shades of gray that can be represented by 8 bits? And so 2 to the 8 is 256. Everyone got that right. I'm happy. I want to go back to the previous question here. Just want to let you know that the ARDMS exam, the SPI, they are working diligently, and they have been for the last 10 years, to reduce these questions with not and except and anything that could potentially have a double negative in it. They've really been working to reduce the number of those questions that are in their question bank. So hopefully you'll see less of those. Okay, next question. An uncompressed signal within the receiver has a dynamic range of 110 decibels. The signal undergoes compression of 40 decibels. What's the dynamic range? That's simple. 110 minus 40, 70 decibels. Everyone got it right. Very happy. What nonlinear behavior creates tissue harmonics? And so this one, the answers that you get are in tissue, not in contrast. In tissue, you get the propagation. So sound travels faster in compressions than in rarefactions. In contrast, we get microbubbles. So we don't get microbubbles without contrast media. Next question. Sound with a frequency of 4 megahertz is created by the transducer. What is the fundamental frequency? The fundamental frequency is the frequency that you're scanning at, 4 megahertz. Very good. Panoramic images. This must have been touched on in the book. Panoramic images expand the image beyond the normal limits of the ultrasound field of view. I don't think we've really gone into much panoramic imaging in the lab yet. Maybe we can do that in the next couple of weeks. Next question. Which of the following will affect the acoustic output? Certainly the transmit power affects acoustic output. Transmit power is in fact acoustic output. They are synonyms for each other. Time gain compensation is amplification in compensation for attenuation, and amplification does not affect acoustic output. Next question. What is the propagation speed in soft tissue? Please, everybody know this one. 1540 meters per second, which can be converted to 1.54 kilometers per second, or can be converted to 1.54 millimeters per microsecond. So there's a lot of conversions you can do with that one. I'm glad to see everybody got it correct. Next question. How does adjusting the overall gain change the brightness of the image? Give it more gain. You're adjusting the amplification of the receiver voltage, and it makes the image brighter. Next question. A coupling medium is applied to the transducer tissue boundary to increase the transmission of the sound wave. And if you want to prove this to yourself, just lift the transducer off of the tissue where you have no coupling, and you will not see any anatomic information. So coupling medium increases the transmission into the patient. Next question. Which is the greatest amount of attenuation? Bone is the greatest attenuator, and we always say air is the greatest reflector. So it's bone. Very good. A digitizer blinks, so you have to read all the answers, and the correct answer is converts voltages from analog to digital form. So it's always going to be converting something from analog to digital. That's what a digitizer does. That's the only potential answer of these four. The location of each dot represents the blank of the echo to return, and that is the time of the echo to return. So that's how we determine position, is measuring the time that it takes to get back to the transducer. Next, if the operating frequency is reduced, then the maximum penetration increases. Next, which of the following is most important in determining the frame rate of a system? And so to determine a frame rate, the depth of view is probably going to be the most important factor that you're utilizing. Next, the number of frames per, or lines per frame and the frame rate determine the blank, or determine the frequency, true or false. Excuse me. That is says false. The frequency, of course, is determined by whatever your transducer you pick up and plug in. So the source always determines the frequency, not any other factors. Next, the sonographer increases the line density from 1 line per degree to 3 lines per degree. What is the most likely consequence of this? So if you're going from 1 to 3, it's probably going to slow down your frame rate or decrease your temporal resolution. Next, which of the following is consistent with improved temporal resolution, higher frame rate? That's what it means. Which of the following is best choice on the image when your system displays reflectors only in a region of the far from the transducer with nothing in the close region? Well, that's not too high a frequency. That has to be the bad compensation. Okay. If you use a higher frequency, you just wouldn't see the echoes in the far field. So if you decrease the frequency, you would see more echoes in the far field, but you wouldn't necessarily improve your echoes in the near field. And certainly if you decrease the output power, you're not going to see many more echoes at all. So the correct answer is adjust the compensation. Take your TGCs and adjust them so you can see that near field. Place these functions in order in which the ultrasound system performs them. And I told you that the receiver performs these functions in alphabetical order. So it's amplification, compensation, compression, demodulation, and rejection. And so B is the correct answer. What is DICOM? DICOM is a protocol for medical imaging. It's how PACS and our imaging systems, whether it's CT, ultrasound, or any other system, talks to the PACS system. Which of the following technology uses long pulses to create an image? This is coded excitation. This was mentioned in the book briefly. Coded excitation does require longer pulses because it is a system by which you have pulses and gaps of pulses in order to create a binary set of information in your pulse. And that is coded excitation, and it helps improve the signal to noise ratio. Next question. A pulse of the ultrasound generates a single scan line as it travels through tissue. Yes, that's potentially true. Most of our scan lines are created by one pulse, though you can have a single scan line created by multiple pulses. It can't create multiple lines. A single pulse cannot create multiple lines, so this is true. Next question. The brightness of the dot corresponds to the strength of the returning echo. That's absolutely true. A sonographer adjusts an ultrasound scan to change the sector size from 90 to 45 degrees. The frame rate is unchanged. What else must have happened? So we've halved our sector size, but the frame rate did not change. So what happened? Well, if one thing is halved, something else must be doubled. And what was halved? Well, it can't be the sector size because we just said that we halved it. So that one's out. The answer is line density was doubled. Everybody got that correct. I'm glad to see that because it was straight out of the book. What is the frame rate if each image of the ultrasound system was created in 0.02 seconds? Well, we just take the reciprocal of that, of the image time, and the reciprocal of that is 50 hertz. Next, a sonographer using a phased array transducer system turns off the multi-focus feature. What is the most likely consequence of this action? Temporal resolution improves. Next question. The acoustic power of a sound beam emitted from a transducer is determined by which component of the pulsar signal? The power is the voltage. Rectification is the change of the signal that comes back into the system from an alternating current to a direct current signal. Next question, how many bits are needed to store 10 shades of gray? So if you have 2 to the 4, which is 16, 16 is plenty of number of bits in order to get 10 shades out of that. So our answer is 4. Next question, which electronic component is required for grayscale imaging? Grayscale imaging is the scan converter. That's where our A mode signal gets converted into a picture, is in the scan converter. Next question, all the following are advantages of a PAC system except that images have a higher resolution that appears in the system's display. That is not correct because all the others are correct. Next question, an uncompressed signal with a receiver within the receiver of an ultrasound system has a dynamic range of 85 decibels. The signal undergoes compression of 30 decibels. What's left? Well, that's 55 decibels. Everyone got it right? That's good. Next question. The sonographer reduces the sector angle from 90 degrees to 30 degrees, so now it's down to 1/3 of what it was. At the same time, the ultrasound system automatically increases line density from 1 line per degree to 2 lines per degree. What will happen to the frame rate? So we double the number of lines, but we take 1/3 of the sector width. Therefore, we're going to have an increase in the frame rate. The type of pulsar generates a constant electrical signal in the form of a sine wave. That's a continuous wave. Glad to see everyone got it. Next question, which of the following procedures is usually pre-processing? And this is what's known as right zoom. You can't do a right zoom because you have to continuously be scanning when you're doing a right zoom. And so that is the correct answer. Let's see. And also correct is adjusting the receiver gain. So I guess because it says usually pre-processing is why I selected also adjusting the receiver gain, because that also can be a post-processing function depending on the machine. Interesting. Well, everyone got it right, so that's good. Next question. If fundamental frequency is 2.5 megahertz, what is the second harmonic frequency? And so the second harmonic is always a doubling of our fundamental. And so 5 megahertz is the second harmonic. And the third harmonic would be tripling it. So 7.5 would be the third harmonic, and 10 would be the fourth harmonic, for those of you keeping score. The display form that represents the depth on the horizontal axis and the amplitude on the vertical axis is A mode. Good to see most people got that right. Which factor is most important when choosing the ultrasound exam? Frequency, depth. Certainly if you have a bigger person, you need a lower frequency because you've got more to penetrate. Which of the following is most important in determining the frame rate of a system? And so the frame rate of a system is the speed of sound in the medium. Again, this goes back to the very first question we talked about. What is the limiting factor? It's the speed of sound in the media. All the following components of an ultrasound are components of an ultrasound system except the alternator. There is no alternator in ultrasound. There's just an alternator in your car. Which of the following choices is best when the image on your ultrasound system is too saturated, which is shown in the picture above, and you would want to first decrease the power, then decrease the amplification. Next question. What is the primary disadvantage of a videotape and computer disk methods of image archiving? If you get a magnet near it, it could erase it. So that's the correct answer. What is the number of shades of gray that can be represented by 10 bits? 2 to the 10 is going to be 200 or 1024. So that is the correct answer. Next answer, which of the following reformats data into an image form for processing, storage, and display? And the answer to that is the scan converter. It takes it from the A mode signal, turns it into an image. That's what the scan converter does. Next question. The number of voltage pulses sent to the transducer each second is called the pulse repetition frequency. The length of each pulse is called the pulse duration. All the following decrease temporal resolution except narrowing the sector. If you widen the sector, again, that's going to increase your temporal resolution. Everyone got that right? Very happy. Okay, which of the following procedures is usually post-processing? So anything that modifies a frozen image is by definition post-processing. Read zoom by definition is post-processing. Right zoom by definition is pre-processing. Adjusting the brightness on the monitor is post-processing because you can do that at any time. And then increasing receiver gain is often pre-processing, though it can be a post-processing function. Next, the sonographer adjusts an ultrasound scan to change the sector size from 90 to 45 degrees. Nothing else changes. What happens? Well, we've halved the sector size, so the frame rate will double. The reciprocal of half is 2, so it's 2 times. Sonographer adjusts an ultrasound scan to double the depth of view from 5 to 10 centimeters, so we're doubling the amount that we're acquiring. What happens to the frame rate? Well, if it stays the same, then something else had to happen. And that the only choice here is the narrower sector is the only thing that would work. Everyone got that right? Very happy. Under certain conditions, an ultrasound system creates each image in, so there's your PRP, your pulse, your frame rate, frame time, excuse me. What is the frame rate? It's the reciprocal of the frame time, or 100 hertz. So everyone got that right. Again, very happy. How many bits are needed to store 258 shades of gray? Well, we know that 256 shades of gray can be stored with 8 bits, so you're going to need more than that. So 9 is the next number, and so 9 is the correct answer. Next question, where does coded excitation take place? This takes place in the pulsar, or also known as the beamformer, is where coded excitation takes place. If the imaging depth of a scan is 15 centimeters and there are 100 scan lines in the image, then the number of pulses making up the scan is 100. So there's 100 scan lines, then that takes 100 pulses. There you go. With frequency compounding, how many pulses are transmitted down each scan line? Yeah. So frequency compounding utilizes one pulse, and it utilizes all the different frequencies within the bandwidth. And so you only need one pulse in order to utilize multiple frequencies because we're using the entire bandwidth generated within that pulse. So 1 is the correct answer. How many shades of gray can be represented by a group of 4 bits? So 2 to the 4th is 16. There you go. Everyone got it right. Which of the following statements regarding pixels is false? And the answer is it displays up to 3 shades of gray simultaneously. That is false. All the others are true. Next question. If 100 scan lines make up an image and the frame rate is 30 per second, then the transducer's frequency is 3000 hertz. And no, the transducer's frequency is selected by whatever you plugged in and its own central frequency or resonant frequency. So that is false. It has nothing to do with the scan lines or the frame rate. The frequency is the fundamental frequency. Next question. What is the number of shades that can be represented by 3 bits? 2 to the 3rd is 8. Moving on. Critical factor in determining frame rate, line density, and imaging depth of is the transducer style. No. We don't care whether it's linear, curvilinear, or some other type of style. What is fundamental in determining frame rate, line density, and imaging depth is different for each of these. It's not the style of the transducer. Frame rate's determined by multiple factors: pulse repetition frequency, etc., line density, and imaging depth. Line density is determined by a setting on our machine, and imaging depth is determined by the button on our machine also. Last question. Yay. A sonographer reduces the sector angle from 90 to 30 degrees at the same time the ultrasound system automatically increases line density from 1 degree to 3 degrees. No other changes will happen. What happens to the frame rate? This is straight out of the book. It remains the same. We've gone down by a third sector size. We've gone up by 3 in our lines per degree. Therefore, there's no change.